Hello again. This is Math 1840 coming to you from the College at a Page, and the title of this lecture is Babylonian and Greek Eras. As always, please be an attentive learner while watching this video. By way of introduction, we move from studying the Rhine Papyrus and ancient Egyptian mathematics supported in large measure from the cradle of civilization spawned by the Nile to Babylonian mathematics, which again was by water, the Euphrates and Tigris rivers combined, and this was a cradle of civilization. Not only did the Ten Commandments come from here on stone tablets, but there was much mathematics. This thing shown here is Plimpton 322, which has, according to some historians anyway, Pythagorean triples with it. So anyway, here is a reading about the overview of Babylonian mathematics. And then, subsequently, Alexander the Great, a Greek leader, a great warrior, conquered fundamentally the known world. And many people talk about the high era of Greek mathematics. And this was achieved in part because there was a very significant flow of both people and ideas across this unified empire. So anyway, astronomy was driving some of the things, and they had major inventions dealing with sundials and water clocks. And so this is the era of Greek mathematics. And emerging from these tributaries, we have three fundamental problems of antiquity. One of them was called squaring the circle, one is called doubling the cube, and the third was called trisecting the angle. And again, I expect to ask you essay questions about these things later. And we start having some very notable men, and in fact a woman, of mathematics. And so I invite you to read and study about Euclid, Archimedes, Pythagoras, Hypatia, and realize that mathematics was not just happening there, but it was happening elsewhere in the Arab world as well. And in the Arab world, unlike Europe, they did not suffer the Dark Ages. And in fact, we sort of leap past the Dark Ages to talk about Arabic mathematics that stayed alive during then, but also one of the people who was a harbinger of bringing Arab mathematics to Europe, Fibonacci. So this brings us about to 1200 AD. And here is problem set 2. There are 4 problems. Part 1, use this figure to prove the Pythagorean theorem. Use geometry and, of course, the image. Parts 2, 3, and Roman 4 prove that there are an infinite number of primes. Prove, you see we're starting to talk about proof now. Prove there are an infinite number of Pythagorean triples. And prove that if p is a prime number, then the square root of p is not a rational number. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself and of each other. We are striving to make a difference. God bless you, and take care. More later.